Now, in this session, what I was talking about in the first session of this board, where Sipser throws stuff at you and you're assumed to be smart enough to come to the same conclusions that he's throwing at you for yourself. In other words, there's quite a bit of reasoning between the lines, so to speak, and you'll get a real taste of it in this session. So I think I'll do some of the same. I've not been handing out homeworks much, so I'll let some of this. I feel I'll give you enough to set you on your way, but I won't do all of it, and ask you to fill in all the gaps for yourself. But I'll certainly give you some strong hints, certainly more than Sipser does, because Sipser students were MIT students, and they are very untypical. Okay. Now I need to refresh, and there was a change of focus actually once it dawned on me what the essential difference is between the first and second examples. Now we're using the same strategy. We're saying, as in the first example, we're going to take V, which we assume is not the empty string, so it's not empty, and we'll take the two cases, either that string V or Y, same reasoning. Let's say it contains only one kind of letter, say all A's, all B's, all C's. That's case one, and the second case is all the rest, all the other possibilities. So in other words, two or three different letters the string contains V. All right. Now, okay. So we're talking about case one. So V contains letters of just one type, all A's, all B's, or all C's. Okay. But now, and here's the difference in focus. This is what I was missing a bit in the previous session. We're going to take that case one and split it up in turn into three more cases, like three sub-cases. So we'll have case 1A, case 1B, case 1C. And case 1A, now remember, you only have one type of letter in case 1, and case 1A is when in V the letter A is missing. So that means V could consist of all B's or all C's. Okay? And case 1B will be when in the substring V your B is missing. So that means your V consists of all A's or C's. And case 1C is when in V there's no C. So your V would then consist of all A's or all B's. Okay? So we have now like three sub-cases to consider. So, alright. So subcase 1A, your V has no A's. Right? So the V consists of all B's or all C's. You follow me so far? If not, rewind. Okay? Alright, and we're going to pump down. Okay? We're going to pump down. So your V to the power 1, if you like, just goes to V0. So that means empty string. So your original string S, which was UVXYZ, now just becomes UXZ, because you've pumped the V and the Y down. You've removed them. You've made them the empty string. So this is what you've got now. Alright, so now there are no A's. There's no A's here or here, let's say. So the number of A's won't change, okay? But the V's, if it had B, if V consists of all B's, then the number of B's has gone down by 1. So that's J. Now we could have a string. If you go back to the previous session, J could be equal to I. Okay, so we could choose a string where that's the case. Yeah, we could choose a language. We could choose a language where J. No, wait a minute. We could choose a string where now we only have to choose one string that can't be pumped, right? So we could choose a string to start with where J is equal to I, and then we pump down, and now J is less than I. Contradiction. Okay. Yeah. So it now can by pumping down, if it had a B, if V had a B in it, and we've got rid of that B or B's in here, so we now have fewer B's than we had before we pumped down. Now if we set J equal to I and then J goes down, well, J is now less than I. But the description of the set is that J has to be greater or equal to I. So contradiction. Right? And similar, similar with or fewer C's. Now, do that for homework. You sit down and cover every possibility, because a lot of details in this proof. All right. Now, okay. So that's 1A. We've got a contradiction. Now 1B, and in this case, in your V, there are no B's. So in your V, there are either all A's or all C's. All right. Yeah. Here. So so your V consists either of A's or C's. Now, if it's A's, if the A's appear, then when you pump it up, now here we pump down. Here now we're pumping up. Okay. Why the difference? Well, to get it to contradict, right? That's the art of a proof. So here we pump down because of 0, and here we've gone up 1, so we're pumping up. But if we do this, let's see. So the B's. I hate it when it pings. Because the two machines ping the same, which is annoying. But I kind of run out of memory. Alright, so okay, so there are no B's in the V, and you pump up. So that means, well, actually here, if you look here, so you've got a sub case now. So case 1, and then the sub case, and now if now remember, if there are no B's in your V, then either your V consists of all A's or all C's. Okay? So now we've got a sub case. So 1B case, what do we call it? It'll call it 1, right? 1B case 1, right? So we have A's in your V, and we got V squared. So suddenly the number of A's in this V squared, that's double what it was when it was V. So we could choose a string where I and j are equal, okay, and then we increase the number of A's because of the V from V to V squared. So we've increased the number of A's, so the I goes up by at least 1, okay. So, but if we chose a string initially where I equals j, that's okay according to the description of the set. But if I now is greater than j, not allowed. Okay, so we've got a contradiction, right? And similar logic with the C's. Okay, so again, for homework, do all possibilities. So again we go to contradiction. So that's case 1b. Now 1c, there are no C's in your, there's no C in your V.